Yes.
Okay. So do travel graphs, or they're also called speed time graphs, right? Travel graphs or speed time graphs. So some of you are familiar with these graphs in physics, right? So I'm going to consider, let's say, if we have a motion of a particle represented on a Cartesian plane like this, so a velocity time graph like that one, and then we have this, right? So the time will be written on the x-axis, and then the velocity v will be written on the y-axis to be on the y-axis. So it's in meters per second, right? So if this is the point O, and then this is A, and then this is B, and then this is point C, right? So for a body that is traveling, that is embarking on a journey, so region O to A, so this represents acceleration. So we know that this represents acceleration, which is constant. So O to A represents constant acceleration, right? And then A to B, that's when the particle will have a constant velocity, right? So for A to B, we have constant velocity, right? So if we have constant velocity, that means the acceleration will be zero. So it means we have zero acceleration if we have constant velocity, which means there's zero acceleration. The body, the car is not increasing speed or decreasing speed, it's just moving at a constant velocity, right? And then for B to C, that's when the car is going to rest. So this is called deceleration, right? So, or retardation. You can call this deceleration or retardation of a body or a car, right? So, how do you find, what's the formula for finding acceleration at O to A? Acceleration. What's the formula for finding acceleration? Um, Adriel?
The acceleration is equal to initial final velocity minus initial velocity over time.
Okay, thank you. So it's final velocity minus initial velocity divided by the total time, right? So final velocity minus initial velocity divided by the total time. So the final velocity for this particular example, so the initial velocity started at 0 here, and then this was the the final velocity was at A. So at O, that was the initial velocity. The final velocity was at A, right? So it's final velocity minus initial velocity divided by total time taken. So the final velocity can be given, can be denoted by v. So if we can say v minus u over t, where v is the final velocity, u is the initial velocity, right? So the initial velocity is at 0 here, and then the final velocity we just put v here. Okay, and then this is where our u is. Okay, so then we need to find the how do you find the total distance? The total distance is given by the total area under the graph, right? Total area under the graph, right? So if you have, let's say for this example, a motion of this body or particle, right? So we're going to find, if we want to find the total distance that it travels, we divide the shape into many shapes that are easier to calculate. So you can say this is shape A, and then this is shape B, and then this is shape C. So you're saying This is equal to area of A plus area of B plus area of C. Area of shape A plus area of shape B plus area of shape C. So A is a triangle, which is half base times height, and then B is a rectangle, which is length times width, and then C is a triangle, which is half base times height. Then you get your total distance. Okay. So the last thing want to talk about is the average speed or average velocity. How do you find the average velocity? Anyone?
I want to try.
Yes.
Total distance divided by total time.
Yes. So it's total distance, right? So it's total distance over total time taken. Total time taken. So that's what gives us the average velocity. Total distance traveled divided by the total time taken. Okay. So those are the necessary things that you need to know if you want to be able to approach questions involving travel graphs in mathematics, right? Okay. So we're just going to look at some few examples here. So everyone's going to say something. We agreed, right? No one leaves the lesson will not end until everyone has said something. So who's going to be our first volunteer?
I can start.
Okay. Thank you, Bradley. Let's see the first question that we are going to have. It's an easy question. Right. So can you all see the question?
No, sir.
No.
Oh, it's not there. How about now? Hello?
Yes.
Yes. Yes.
Yeah.
Okay, Bradley. You can start. Number 13.
Right. So number 13, it says the diagram shows the speed, the time graph for part of a car journey. Calculate the total distance traveled during the 10 seconds.
Yes.
Saka since 30 kutsvaga the distance traveled,
Uh,
the area, notora total area under the graph.
total area
Saka
under graph.
under
Yes.
the graph.
Yes.
Saka formula ekuwana iri trapezium half.
Okay, so you're just going to so it's a trapezium, right? What's the formula?
It's half
Mm-hmm.
times bracket a plus b times h.
Okay. Yes. So which means we what?
Right.
So we
So
have
half, then a. So a is going to be 8.
8.
Then b is going to be 10.
And then our height.
It's going to be 10.
It's going to be 10, right? So our A is going to be, so this A and B are what we call our parallel sides here that I've marked here. So our A is going to be, you said 8 is from here to here, the shorter side. And then B is from 0 to 10. That's why I said 8 plus 10, right? And then the height is from 0 up to 10. So which means what will be the total area? If you say 2 into 10 with 5,
So
what
it's like it would be 90.
it will be what?
18 by 5 to 90. 90
90.
meters.
Okay. So the total distance is
Yeah.
90 meters. Okay. Thank you, Brad. And then the next one. Who wants to try the next one?
I want to try the next one.
Okay, Ruimbo.
So find the acceleration. Acceleration, we said final velocity minus initial velocity divided by time. So
Yes.
14 minus 0, that's 14 divided by 5. That's
Okay. So
2.8.
V minus U over T. So the final velocity was what?
14
Uh,
minus 0
divide
divided
by
by 5.
divide by 5.
5.
Okay. So what do we get?
2.8.
Okay, that's 2.8. So that's meters per second squared, right? Meters per second squared. Okay. And then, so this was part A. And then part B. Anyone wants to help us part B? A different.
I can.
Okay, Andrew, yes, please.
So we are looking for the area of a trapezium.
Okay. So the total distance is
Mm,
equal to total area, right? What shape is that?
trapezium.
Okay. So it's half
Mm.
A plus B times height, right? Which is equal to half. What
It
is
is
our
equal
A?
to our A is going to be 10.
What?
Our A is going to be 10.
10 plus
15.
10 plus 15. And then our height?
It's going to be 14.
14. Okay, so what
Yeah.
do we get? And then what do we get? You calculate.
10 plus 15. We get 175.
Okay, 175 meters. Okay. Thank you. Thank you, Adriel. Okay, so that's the first two questions. Let me put the second set of questions. So we have people who haven't said anything, right? We also want them to say something. Arno and oh, it's Arno, right? Wait, okay, yes, she's there. Is Arno there?
Yes, sir.
Yes. So please, can you do that one?
Okay, so we're finding the deceleration of the car
Yes.
in the final 8 seconds.
Yes.
So
How do you find the deceleration of the car in the final 8 seconds?
I'm not sure, sir.
Anyone to help her? Is there anyone? Bradley? Bradley, are you there? Okay, Ruimbo, do you want to try?
I think that we say 24 minus 16.
Okay. So the acceleration is equal to the final velocity minus initial velocity over time. So what is our final velocity?
24.
24 minus the initial velocity
16.
16 divided by the time. What is the time taken?
8.
8, right? So for no, we want the deceleration in the final 8 seconds. This is the acceleration that we want to find in this period here, from 16 to 24 when the car was going to rest. So we're saying final velocity is 24 minus the initial. It started on 16 divided by the time that it takes. 16 to 24, there is 8 seconds here. So we get what do you get? 24 minus 16. That's 8.
22.
24 minus 16 divided by 8.
22.
It's 8, right? So it's 8 over 8, which is what? Which is 1. So it's 1 meters per second squared. Is that so? Hello, guys.
Yes, sir.
Okay. Okay. So that's 1 meters per second squared, right? Okay. So if they say deceleration, right? If you get a negative, you don't put the negative, right? If they say the deceleration of the car, obviously you have to get you'd have to get the so we have to get a negative. The final velocity it's 12, right? So so they made a mistake here. The final velocity is 12, right? You guys were agreeing with me. Why were you agreeing? Hello, guys.
Yes.
Why were you agreeing? I put 24 instead of 12. So what do you get now?
Minus 4.
And then what's the final answer? So you get minus 0.5 meters per second squared. Okay, so I made a mistake. I put 24 instead of the so I keep now I'm getting confused. So let us start over, guys. Sorry. The final velocity is what? The final velocity is going to be 0, right? Minus the initial velocity was 12, right? We started the car goes to rest, so the final velocity is supposed to be 0 minus the initial was 12 divided by the time, which is 8. So keep making I don't know what's wrong today. So we get that answer. So what do you get, Bradley? Hello, guys.
We get minus 1.5.
Okay. Yes, so get minus 1.5. Sorry for that blunder. Don't know what's happening today. Okay. So if they say I was saying if they say deceleration, right? Say calculate the deceleration. So you won't put the negative. So the deceleration is 1.5 meters per second squared. But if they say calculate the acceleration, right? That's when you put your answer with a negative. Is that clear? Okay.
Yes.
So, and then for part B, who's doing part B? Hello, who's doing
Yeah,
part
let
B?
me try to.
Yes, please, Bradley.
Like I say, the total distance traveled during the 24 seconds.
Yes.
So, total distance traveled is equals to the distance under the graph. Like our
Okay.
shape is a trapezium.
Okay.
So
So
our formula is equals to half bracket a plus b times
right.
h.
Yes. So what do we
So
get?
our a is 16
A16
plus b 24
plus 24 and then what's our height?
it's 12.
12. Yes. So what do you get now? Get into
Let me
6.
calculate.
Okay. 24 plus 16 times 6. Get what? 240,
Mira.
right?
Yeah.
Okay.
Mm.
240 meters. Okay. Thank you, Bradley. Okay. And then number 14, the diagram shows the speed time graph of a train journey between two stations. Find the acceleration of the train during the first 40 seconds. Arno, this one is yours. Is she there?
So yes,
Yes, please.
so we're going to find our initial final velocity, which is
Which is what? 12.
12
Yes. Minus the initial.
minus 0
Yes. Divided by the time.
over the time is 40
Yes. So what do you
seconds.
get? What do you get?
Mm, we
So
get
it's
12.
12 over 40.
We get 0.3.
Okay, so it's 0.3 meters per second squared, right? Okay.
Yes.
Yes, thank you. And then part B. Part B. Who's doing part B? Wants to calculate the total distance? Adriel. Munash.
Easy.
Yes.
The total distance is equal to the total area of
Yes.
the graph of what's under the graph.
Yes.
So we have a shape A, B, and C where A and B
Okay.
are triangles and this is the sorry a rectangle.
Okay.
So the first area for A is going to be half base times height, which our base is 40. That means our
Half
that
times
means
our base is 40 and then our height.
our height is going to be 12. 12, yeah.
Yes. So what do we get now?
We get 240.
240. Okay.
Yeah.
And then for B, area for
Then for
shape
B,
is
it's going to be length by width.
which is going to be
Eh, Our length is 50 minus 40. What, 200? It's a 200 210.
210. And then our width,
Yeah.
our width.
Our width is going to be 12.
Okay, so what do we get?
2520.
2,520. And then for shape C, shape C,
Shape C, the base it's half base times height, so the base is going to be 50.
okay, base is going to be 50. And then the height
And going to be 12.
is going to be 12. Okay. So what do you
Yeah.
get now? What do you get?
300.
Okay. So that's going to be 300. So the total area, which means the total area will be what?
The total area is going to be 3,060. 3,060.
Or 300 plus 2,520 plus 240. You get what?
3,060.
3,060. Okay.
Yeah.
3060. Okay. So thank you for trying.
Yeah.
Okay. 300. Huh? Which numbers did you add? I'm not getting I'm getting 2,860. Is that so?
I did 240 plus 300 plus 2,520.
20.
Yeah.
2,520 plus 240 plus 300. Okay. 3060. Okay. So I remember me. Okay. Oh, that's fine. So we only have 8 minutes left, and we have just one last question. So who's going to do the last one? Who's going to volunteer?
I want to do it.
Okay, thank you, ma'am. Okay. Okay, Ruimbo. Right. You can lead us.
Number 9.
Yes.
Find the deceleration of the curve between 10 and 13.
Yes.
So we're gonna say 7 and 8. For final velocity, it's 0.
Okay, final velocity is 0 minus the initial
It's 8.
8 over the time.
Time is 13 minus 10.
Which is 3, right? Okay,
Yes.
so what do we get now?
We get negative 2,67.
Okay, negative 2, again, just 2,7, right? So if they say deceleration, we don't write with the negative, right? So which means the deceleration is 2.7 meters per second squared. Is that so?
Yes.
And then the next one, you can quickly do the rest of the questions. Now we're running out of time.
So find total distance traveled during 13 seconds. So we split the graph into two shapes. So for the rectangle, we're
Okay,
gonna say 10 times.
remember, isn't it faster to just say to just calculate it as one shape?
Um,
You're not used to that.
okay,
Yeah? It's
okay.
okay. You can use
Mm.
your method.
Which method should I use?
Oh, your method, it's fine. Two shapes,
Okay. So yes,
A
rectangle
and
and the triangle.
yes,
So for a rectangle, we're gonna say 10 times 8, we get
let
80 meters.
okay, 10 times 8, we get 80. And then for
Then
B,
half base times height, we get half times 3 times 8.
half. And what do you get? Times 3
We get 12.
you get 12 meters. Okay. And
Then
then
we
so it
add
means the total
80 plus 12, 92 meters.
92 meters. Okay. Thank you, 92 meters. And then 17, number 17. Is there anyone who wants to quickly rush through number 17? Quickly, we only have 4 minutes left. No one. You can go ahead, Urubimbo. Sorry.
Okay. Acceleration between 20 and 40 seconds.
Yes.
So we're gonna say final velocity, which is 4.
Okay.
So our final
Uh,
velocity is 4. Our
okay. 4.
initial velocity is 2.
Uh-huh. Time.
Uh, time it's 40 and 40 minus 20.
So that's 20, right? Okay.
Yes.
So what do you get?
We get um 0.1.
Okay. 0.1. Okay. So the answer is 0.1 meters per second squared. And then the total distance. Now I want to find the total distance traveled.
Total distance, I want to split it into 3 shapes: triangle, rectangle, and the trapezium.
Okay, it's okay. 3 shapes. Okay.
So for the triangle, we're gonna say half
Base
base
times
times height,
yes, and then
half
we get
times 10
uh
times 2,
okay. And then what do you get?
10 meters.
Okay, the 10 meters there. And then for B,
For B, the rectangle, say 10 times 2, length times width.
okay, so it's 10 times 2, and then you get what? 20.
20.
And then for C,
Then for the trapezium, which is half A plus B, multiplied by height.
okay. And then so it's what is our A and what is our B and what is our height?
Our A is 2.
Mm-hmm.
Our B is 4.
Uh,
Then our height is 20.
okay. What do you get now?
We get 60.
Okay, so we get 60. Okay. So now the total distance.
Total distance is 90 meters.
Okay, 60 plus 20 plus 10. Okay, so we get 90 meters. Okay. Okay, so is there anyone with a question on what we did today? Anyone with a question? Anyone? So that's all we had for today. We did travel graphs. or speed time graphs. Thank you for your time, ladies and gentlemen. We'll meet again